So now to go the other way, so to invert an angle from radians to degrees, you're simply going to multiply by 180 degrees over pi. And then again, they want me to draw each angle. So pi over 6. So again, I'm going to have to multiply this angle by 180 degrees over pi. Remember to convert, when you're converting into radians, you should get the pi's to cancel out. So this is how I know that I want that pi symbol to be in the bottom of this conversion formula. So again, I can cross out those pi's. I have 180 degrees divided by 6, which is going to give me 30 degrees. So pi over 6 is equivalent to 30 degrees. Again, when I sketch this angle, there's my initial side, and again, a 30-degree angle is rotating in that clockwise direction. 3.89. Now notice this doesn't have a pi in it, so what does this tell you? This is going to be an approximate radian angle measurement. I'm still going to multiply by 180 degrees over pi. Remember, all they've done is they've multiplied out that pi. So this is not an exact radian, this is an approximation. So again, I'm going to take my calculator, 3.89, multiply it by 180, and then I'm going to divide by pi. And the pi symbol is that second caret symbol. So 222, we always round to 3 decimal places. So in degrees, 3.89 radians is approximately equal to 222.881 degrees. And don't forget that degree symbol. So when I sketch an angle of 222.881 degrees, again, here is my initial side. Again, I have to go about 42 degrees more than 180. So this angle has a terminal side down there in quadrant 3. Negative 5 pi over 3. Again, I'm going to multiply by 180 degrees over pi. Again, the pi symbols are going to cancel out. I know 3 goes into 180 60 times, and 5 times 60 is going to give me negative 300 degrees. So again, when I sketch negative 300 degrees, again, I know my initial side is on the positive x-axis. Again, here's my negative 90, negative 180. Negative 180 plus 90 is negative 270. So I know I'm going to have to go another negative 30 degrees, which is going to put my terminal side here in quadrant 1. Okay, so it's very critical that you always show that direction. That way we know there's a big difference if you look at the angle going at clockwise versus a counterclockwise. Negative 13 pi over 6. Again, I'm going to have to multiply by 180 degrees over pi. Pi symbols cancel. 6 goes into 180 30 times. So 13 times 30 gives me negative 390 degrees. So again, I know that this is going to be going around more than one revolution. So there's my initial side. So again, if I could make one full revolution, I've gone negative 360. So then 390 minus 360 is going to give me, I have to go 30 more degrees. So that's going to put this terminal side down here in quadrant 4. So that's how you can convert an angle from radians into degrees. So here's just some common angles in radians. So draw the given angles on the coordinate plane and convert to degrees. So again, to convert to degrees, I'm going to take this and multiply by 180 over pi. Again, the pi symbols are going to cancel out, and 180 divided by 4 is going to give me 45 degrees. So again, here's my initial side, there's my terminal side. 7 pi over 4. If I want to convert this into degrees, I'm going to multiply by 180 over pi. The pi symbols are going to cancel out. And again, I can multiply 7 times 180, and then I'm going to divide by 4. So that's 315 degrees. And 315 degrees, again, I'm going in a positive direction. So there's my 90, 180. 270, I have to go another 45 degrees. 7 pi over 6, I'm going to multiply by 180 degrees over pi. Pi's cross cancel. I know 6 goes into 180 30 times, and 30 times 7 is going to give me 210 degrees. So again, here's my initial side. So there's 90, 180, I have to go another 30 degrees. Again, make sure you show the direction. 5 pi over 12, going to multiply by 180 over pi. Pi's are going to cancel out. So 5 times 180 divided by 12 gives me 75 degrees. So again, here's my initial side. My terminal side is going to be still in quadrant 1 because it's less than 90 degrees. Again, make sure you show that direction, that it moved in a counterclockwise direction. Negative 3 pi over 4. Again, I'm going to multiply by 180 over pi. Pi's are going to cancel out. And then 3 times 180 divided by 4 is going to give me negative 135 degrees. So again, here's my initial side. So again, here's my negative 90. So I have to go another negative 45 degrees. So that's going to put the terminal side down there in quadrant 3. Make sure you show that you've rotated in that clockwise rotation. 9 pi over 7, I'm going to multiply by 180 over pi. The pi's cancel out. So 9 times 180 divided by 7 is going to give me approximately, and again, the squiggly equal sign, that's your approximation symbol, in case you haven't seen that or it's been a while since you've seen it, 231.429 degrees. So again, my initial side is on the x-axis. So here's my 90, 180, so I have to go another 51 degrees, approximately. So negative 16 pi over 11. Again, I'm going to multiply by 180 degrees over pi. Pi symbols cancel out, which is what you want. So 16 times 180 divided by 11 gives me negative 261.818 degrees. Notice I am always rounding to 3 decimal places, which we will always do all year long. So again, my initial side is on my positive x-axis. So there's negative 90, negative 180. Now, if I went a full other negative 90 degrees, that put me at negative 270. So notice 261 is about 9 degrees less than 270. So I'm going to draw my terminal side pretty close to that y-axis. So notice my terminal side is up there in quadrant 2. 11 pi over 4. Again, I'm going to multiply by 180 degrees over pi. The pi symbols cancel out. 11 times 180 divided by 4 is 495 degrees, which you can see is greater than 360, so it's going to be more than 1 revolution around. So here is my initial side. So if I go around 1 revolution, that's 360. So I want to take that 495 degrees and subtract from it 360, which is going to tell me that I have to go another 135 degrees. Well, here's 90. Again, I know that 135 is less than 180, so that's going to put my terminal side here in quadrant 2. But you need to make sure you always show that 1 full revolution. So that's how you can sketch your angles, and you can convert angles from degrees to radians and radians to degrees.